Good Friday morning, everyone, and welcome to our Friday morning class. Some of you guys may have noticed you only are going to see one video this morning. I figured a way out to have the longest video possible without breaking it up into 15-minute segments. No, I won't make it that long, but you won't have to cycle through multiple videos for Friday's classes anymore. So we figured a way that you don't have to do that anymore. So without further ado, let's go ahead and get started here. Our reading for this morning is going to be called the On the Trail of the Wolverine. So we think Wolverine, a lot of us think of Michigan. We think of Michigan athletics and Michigan sports. Here's what a Wolverine actually looks like. Doesn't look like a baseball or football or basketball player. He looks like this, or she looks like this. So on the trail of a Wolverine, you can see that Wolverine like galloping through the kind of a forested area. It's written by Jack Latimer. You can see the Wolverine table of contents. One fast, sneaky animal trapping a Wolverine caught, missing the chase, and what's next for M56. So one fast, sneaky animal. What do a Wolverine and a bank robber have in common? Neither wants to be caught. And either finding one can mean a high-speed chase, exciting chase. One group of scientists learned this the hard way. Wolverines are meat-eating animals. Like lions and bears, scientists know a lot about lions and bears, but they haven't had many chances to study wolverines. There are good reasons why. Wolverines live in harsh, snowy places around the world. These places are hard to reach, but wolverines have no problems traveling in the snow. They have wide feet that work like snowshoes and let them walk on the deep snow. So you can see an example of some snowshoes. You can see they're kind of an addition to your normal boots that you're wearing into the snow. You see this person actually has some what we call gaiters, not G-A-T-O-R like alligator, but gaiter, G-A-I-T-E-R. Gaiters has something that it kind of goes around your shoe on the bottom and covers over the top of your shoe, brings up kind of like your shoe covering a little bit higher. It really prevents like snow and things like water or sticks or things getting down into your shoe. So this is a Wolverine running across the snow. You can see about the approximate size of a Wolverine, very furry creature. They're built like small bears, and Wolverines live in snowy areas. So I'm reading all the captions here. It's important to read the captions. Wolverines are also fast and fierce. With their sharp teeth and claws, they aren't afraid of anything. Even scientists study Wolverines because they want to learn more about them. They are also worried about the future of Wolverines. Wolverines give birth in deep dens they dig in the snow, but many cold places around the world are getting warmer. When snow and ice start melting, Wolverines have big problems because they need deep, deep snow to build their dens. Wolverines travel from mountain to mountain hunting for food. People keep moving into these areas and building on the land. That makes it harder for Wolverines to find food. Are there enough cold, wild places left for Wolverines? Scientists hope that one Wolverine would give them some answers. So you can see this Wolverine sprinting away. Wolverines are always on the run through rough land or deep snow. It's kind of a cool shot right there. Trapping a Wolverine. A group of scientists headed deep into the wilderness of the state of Wyoming. They wanted to catch a Wolverine, but it wouldn't be easy. Wolverines don't live in groups. They mostly live alone and on the run. These animals travel hundreds of miles over tall, icy mountains. They can run more than 35 miles in one day. So just for reference, a marathon is 26 miles. So these guys are doing more than 11 more miles than a marathoner does in one day. The scientists traveled for hours on snowmobiles, snowshoes, far from roads and other people. They carried several large wooden traps. The scientists put meat inside each trap for bait. They hoped a Wolverine would smell the meat and go inside. If a Wolverine pulled on the bait, the door would shut and the animal would be trapped. The scientists had to wait to see if their traps would work. So you can see in this caption, finding Wolverines is hard work. So if you're into going out into the outdoors, traversing across some tough terrain, maybe being some sort of scientist that traps Wolverines would be interest of you. The scientists couldn't check each trap every day because the traps are so far apart. They put a radio transmitter on each trap. A radio transmitter is a small radio that's often used to track animals. The transmitter sends out a beeping signal once a day when the door on the trap shut. The signal beeped 2 times every second. The double beep means it was time to check the trap. That's smart. There's a little wolverine. Wolverines travel a lot of territory, so scientists set traps over a large area. Oh, look at that guy right there. The scientists are excited to check the closed traps. Even though they had to travel for hours to reach them, sometimes they found an empty trap. A bird may have landed on the door, causing it to slam shut. Sometimes there was an animal inside the trap, but it was the wrong kind of animal, like a bobcat or a fox. Scientists let these animals go. Then there was an old, hungry mountain lion that got caught over and over. When the scientists opened the door, she didn't seem to want to leave. She was waiting for more food. That's probably what I would do. In December 2008, the scientists traveled to a trap that had closed. They heard an animal pacing inside. They heard growling, and they recognized the sound. Finally, they had caught a wolverine. So you can see a little wolverine here. Maybe that's the meat kind of looking like it. That's an interesting trap. It almost looks like a little warm, cozy den. I suppose if you're going to trap an animal like this, it's cold, and they want to build a place where, they can stay for several hours or sometimes days until the scientists can get there. So that makes sense. They have food and they have a little warm shelter. Wolverines have strong jaws and teeth that can crush bones, and they eat just about any animal dead or alive. Look at those things. Wow. Now that's some scary looking teeth. Cut! The wolverine was very angry. Getting him out of the trap was going to be just as tricky as getting him in the trap. The scientists had to be careful. Wolverine jaws are so strong they can bite through frozen meat. To avoid trouble, the scientists shot a dart into the trap. The dart had a drug that would put the animal to sleep for a very short time. A few minutes later, the growling stopped. The wolverine was asleep. Or so they thought. No, I'm just kidding. Oh, there's a little wolverine. The scientists took the sleeping wolverine out of the trap and gave him a name, M56. Oh, such a nice name. He was young and weighed about 32 pounds. Next, they put a small radio tag under M56's skin. They also placed a GPS monitor collar around his neck to collect information about where he traveled. GPS stands for Global Positioning System. It uses signals from satellites above Earth to record information. By now, the drug was wearing off. M56 was waking up, but he was still sleepy. The scientists could put him back in the wild yet. He might sleep too long and freeze in the snow, or a large animal might attack him, and he wouldn't be able to fight back. Good point. A scientist places a radio tag on a sleeping wolverine. These tags can last for 5 to 7 years. Radio tags and GPS collars do not hurt the animal. M56 name. Scientists use numbers to track all the wolverines they find. They put M in front of the name for male or female. Oh, M for male and F for female. 56 means that he's a male and that he's the 56th wolverine that scientists have trapped. Oh, scientists are so practical. I get it now. M56, so male 56. Or it could have been F56, female 56. Oh, there he goes. Look at him. The scientists lined the trap up with the pine tree branches. They placed M56 back inside to let the drug wear off. The pine branches would help keep him warm. They closed the trap and left. The next morning, they returned. M56 was awake, and he was very, very angry, and no one wanted to get in his way. The scientists stood behind the trap and pulled the door up. M56 ran out of the trap and into the woods. Soon, he disappeared. Yay, there he goes. M56 began running as soon as the trap door opened. Missing! All went well for a few months. Scientists kept track of M56 as he moved around. Sometimes a pilot in a small plane checked on him. The pilot would fly low so he could search for the wolverine. As soon as he flew, he often heard a signal from M56 tag. And then, in March 2009, the pilot lost the signal. M56 was gone. The pilot searched and searched but couldn't find him. The scientists guessed what had happened. Young wolverines often leave one area to find their own territory in another area. M56 was on the move, but which way had he gone? Would the scientists ever be able to find him again? Mark Paciulli is a pilot who followed M56. His plane could fly close enough to the ground to find a wolverine. And that could be also kind of a cool, like a scientist pilot that kind of scours the ground for tagged animals. Interesting. Tough loners. Scientists know that each wolverine calls area very. Try that again. Scientists now know that each wolverine calls a very large area home. Radio tracking has helped scientists learn that a male's territory can be up to 448 square miles. A female's territory, good. Can be up to 174 square miles. That's quite a lot, except for when a female has babies. Wolverines live alone. The chase. The pilot kept flying over the rocky, snowy mountains looking for M56. Finally, in April, he heard something. It was M56 signal. M56 was on the move, and the chase was on. The pilot searched for M56 signal every chance he got. He had to stop at night because flying over the dark mountains was dangerous. Fair point. One day, a few weeks later, the pilot heard the signal near the ranch. He landed his plane on a dirt road and got out. There was M56 eating a dead cow. Wow, eating a dead cow. The pilot was thrilled to be so close to him. So the pilot found M56 in Granite Mountain. I thought Granite Mountain was in Arizona, but I'm wrong. Soon, M56 was running again, but bad weather stopped the pilot from flying. When the weather cleared, the pilot found M56 from another group of mountains to another. That is. Then M56 turned south, the state of Colorado. Wolverines hadn't lived there since 1919. Scientists wondered if wolverines could be expanding their habitat. This would be good news for wolverines and wild animals in general. M56 crossed big highways. He circled around the edge of a town. He kept going south. Then in June, M56 crossed into Colorado. The scientists cheered as though M56 had just won a big race. So, M56 took one of the longest trips the scientists had ever seen a wolverine take. So, this yellow line is a highway. Look at this highway. Highway, highway, highway. The red line is M56 path. So M56 came in and said, whoop, highway, let's not cross that. So they started going down this way, down this way, down this way, down this way. And he's like, ooh, that's a big mountain there. Let's go back over to the right. Heck, let's just climb that mountain and up and over that mountain. M56 went. What a heck of a trail he left there. What's next for M56? Tracking M56's journey had felt like watching a very long race. The Wolverine had traveled 585 miles. Radio tracking wild animals like M56 is one of the best ways for scientists to learn where these animals live and how far they travel to survive in a changing world. Scientists are waiting to see what M56 will do. Will he set off on another journey? If he does, then scientists are ready. The chase will start again. M56 stopped in Rocky Mountain National Park in the state of Colorado. At the end of 2010, he was still there. Catching wolverines. Over a 10-year period, the scientists of the World Conservation Society Greater Yellowstone Wolverine Program, well, that's a mouthful there, World Conservation Society Greater Yellowstone Wolverine Program in the western United States captured and then followed 38 wolverines. All these animals taught the scientists about the habitat that the wolverine needs. A young male called M56 caused the most excitement. The writer and editors would like to thank Chris Inman for sharing M56's story. To learn more about wolverines and wolverine research, visit the Wolverine Foundation website. Let's see if we can do that. Wolverine Foundation website. Maybe let me copy and paste that. Let's see. Wolverine Foundation website. Let's go. Paste. No, it didn't work. That was an email. Let's see here. Maybe wolverinefoundation.org. Wolverine Foundation. Let's see. There's the Wolverine Foundation. There's the Wolverine. So that's kind of neat. The Wolverine Foundation. A little bit about us. Supporting the work. Resource, news, facts, gift shops. Contact us. Store. I wonder if M56 is still around. I don't know if I see anything on here. Maybe that can be kind of like your side homework project if you want to do it. See if you can find out about M56. See if M56 is still there. Maybe I can check news, Wolverine news. I don't see anything about M56. 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 I don't see anything about M56. Oh my gosh, look at that Wolverine. Wow. Yeah, I don't see anything about M56. Let's see here. I'll put it in here. M56 Wolverine. Let's see. Epic Journey, ends in North Dakota. Oh, let's see. I hope he didn't pass away. Epic Wolverine Journey ends in North Dakota. Oh no. In 2009, M56 Rocky Mountain National Park was the first documented sighting in the state in a century. North Dakota Fish and Wildlife Department knew that the dead Wolverine was special even before they performed a necropsy. It was the first Wolverine reported in the state in almost 150 years. A rancher had killed it illegally in late April for harassing cattle and then given its carcass to the agency. The managers weren't expecting to find a radio transmitter in its abdomen. Oh, that's too bad. Oh, M56 passed away in, what was that, April? When did it? Oh no. It looks like it, yeah. It's too bad. M56 animal traveled at least 2,000 miles and inspired a reintroduction program to Colorado. Bob Inman. So there's Bob Inman, the guy who shared the story. Oh, it's too bad. So he died in April of, no, I'm not finding it. Illegally killed in April for harassing a cat. Okay. So April of 2016, it looks like. Oh, that's too bad. Well, I guess that kind of puts a sad ending on that story, but we'll push ahead. So let's go in and open up our canvas. Logging in. And, alrighty. All right, so here's your work for Friday. You have this column right here on page 1, and then on the next page you have this column. So let's look at our Friday work in the morning. So before we do an accelerated learning, I want to talk about our mini mystery science. So let's go to our mini mystery science. Go over to modules. And then, oh, sorry, not modules. You go over to discussions. I'm sorry, you're in discussions, not module, discussions. And then we're looking for the one that's due on January 29th, which is right here, mini mystery science number 16. And here it is. Do you think mermaids are real? What do you think sailors really saw? What's the most amazing thing in the bonus box? We go, oh, good job, Brandon. Brandon already did it. Thanks, Brandon. So if you click the link, it takes you here, and here is the question. Are mermaids real? Dun, dun, dun. I know we talked about mermaids a few weeks ago. So our friend Doug here, I know you can't hear him right now, but this is where it kind of comes from. So this is what you guys should be doing. You should watch that, and then you answer the question. Do you think mermaids are real? What do you think sailors really saw? What's the most amazing thing in Doug's bonus box this week? And then you hit reply, and I want you to reply by answering these 3 questions. You can also reply to Brandon if you would like. So that's the first part of what I want you to do. Let's go back to dashboard. Let's go into here. All right, so that's the mini mystery science number 15, or no, what's 15? I'll have to change that. It should be 16. Mini mystery science number 16. You know what? I'll just go ahead and do it right now. That way I don't forget. So if I go in here, I'll go into slides, and then I will go into, it should be the very first one. That's the one I just opened up last. We'll go into here, and we'll have to wait till it loads a little bit, and I will change that 15 right there. That should say 16. Delete, delete, 16 space. And then if I go back into here, but Mr. Dooley, it says 15. Watch what happens when I hit refresh. Refresh. Now it'll say 16. Oh, whoops. What did I do wrong? 16. Maybe this thing wasn't refreshed. I promise you it's going to say the right thing. That's refreshed. Now let's go back in here. Let's refresh it. There it is, 16. Okay. So make sure you guys do Mini Mystery Science 16. It is, are mermaids real? Now let's go into our Canvas again and open up our reading, our Canvas reading, our virtual reading course. It's the one with the little kid. You ever notice that the kid's reading really fast? We'll go to modules, and then we'll go to January 29th. Oh, it was just right there, and I just over scrolled just a little bit. This one's called commas for transitions. So commas for transitions. Why punctuate? Sometimes punctuation can seem like an unnecessary chore. Why does it matter if you use a comma or not? That's the subject near and dear to the heart of this man, Barnaby Quip. Quip. Barnaby Quip.
Oh, you're back again, are you? Couldn't stay away from me, eh? Let me guess. Is it my suave and debonair looks? Perhaps it's my rakish charm. Oh, let me guess. It's my wit. My charming wit. My razor-sharp wit. My wit that knows no end. Wait a minute. Wait a second. There's a few of you out there I don't recognize. I don't think all of you have met me, have you? Well, then, let me introduce myself. My name is Barnaby Quip, and these are my headquarters. Aha! Headquarters to what, you might be wondering? Am I a spy? Do I run covert operations? Am I a secret agent working for a higher cause? Well, as a matter of fact, I am. But I don't work for a secret government, and I don't get to drive fancy sports cars in big-budget films. I work for myself. I'm an English linguophile. Well, let me explain. I love the English language. I love words. Language and words are my calling. Now, some people are called to be teachers. Some are called to be doctors. Some of you may know what you want to do when you get older. Me, I always knew that I wanted to be in grammar mechanics, that sort of thing. How did I know this? Sneezing. It's true. Anytime I get near anyone who's abusing the language in their writing or speaking, I would sneeze uncontrollably. It's true. It would drive my mother bananas. Stop sneezing, Barnaby, she'd say. I can't help it. Someone over there didn't use a comma. So, ever since I was a child, it's been my hope, my dream, no, my mission in life to rid the world of bad grammar, punctuation, and writing. At the very least, I can't stand all the sneezing. So, listen carefully. Language is power. The proper use of words and language can take you anywhere. So here, in my headquarters, my windows on the world, as I like to call it, I brought my boyhood dream into action.
Okay. So why does the actor need punctuation? Special punctuation agents. So why does he need it?
Through my high-power telescopes and monitors, I keep a watchful eye on what goes on out there. My special agents report any bad examples of grammar, punctuation, or writing as they happen. So who knows? Maybe I've got my eye on you. Now, earlier today, I had a call from Sabrina, one of my top punctuation agents. She's hot on the trail of some missing punctuation in a local theater. A regular whodunit. Hey, maybe that's her now. Sabrina, is that you?
I'm here, Barnaby.
I hear you're about to pull the plug on a bad actor.
You could say that. I'm at a community theater in Texas. They're holding auditions for a new play tomorrow, and I've found one actor who desperately needs our help.
Something rotten in Texas, eh?
Yes, and it's rotten punctuation.
To punctuate or not to punctuate? That is the question.
I think the answer is a resounding yes. Without punctuation, all the sentences are running together.
Well, now that the dirty deed has been done, get in there and undo it.
Yes, Chief.
Where's our young thespian now?
He's in the theater now. I've been listening at the door all morning.
Well, good luck, Sabrina.
Thanks. I'm going in now, Barnaby.
We sat down to our terrible dinner that night, and she said to us, "Did you
Hold
boys
it right there.
Hey, what's going on? Who are you?
Don't say another word.
Why not?
I mean, not another word of that monologue you've been rehearsing.
Why not? You with one of those candid camera shows?
No, not exactly. but I have been listening at the door.
Why? You with the show or something? Are you an acting coach?
No. Sabrina, special agent, punctuation.
Punctuation. What are you talking about? I'm an actor.
All the more reason you should be aware of your punctuation. It plays a very big role in your profession.
You mean in acting? Come on.
When you act, do you ever raise or lower your voice to emphasize something?
Of course.
Have you ever used a hand gesture to make a strong point?
Yeah.
Well, those actions are equivalent to the punctuation we use in a sentence. When a writer, or in your case a playwright, writes words for you to say, he or she uses punctuation to let you know when to stop, when to pause, or when something should be shouted out. The writer is helping you. He or she is making your job easier by giving you clues on how the sentences should sound.
You know, I don't think anybody's ever told me that.
Yes, I could hear that. One of the first rules in punctuation, and probably in acting too, is to use your ears. Listen.
Yeah, I'm a good listener. I could do that.
Okay. So, other than sneezing, why does Barnaby Quip want to get rid of the world of punctuation mistakes? Well, because language is powerful if used correctly. Without punctuation, all the ideas in sentences just run together. So yes, it needs a comma. What types of sentences should include a comma? In this video, the punctuation agent Sabrina shows Bryce, an actor, how commas should be used in sentences with an unnecessary word or phrase at the beginning.
Let's move on to the next sentence. Your next sentence is, well, I guess I can think of one other thing. You need to put a comma after the word well.
Why?
Because it's an unnecessary word.
Like the appositives and non-restrictive phrases?
Yes. Words like well and oh are what we call mild interjections. Words that name or address people like hey you, nurse, or Bryce are treated like mild interjections. If I said, Bryce, your monologue is in desperate need of punctuation, you would need to put a comma after Bryce.
And if I asked you, why do you like being a punctuation agent, Sabrina? A comma would come before Sabrina.
Yes.
What about words and phrases like on the other hand, next, or first?
Those are called transitional words and phrases, and the rule is the same. They're called transitional phrases because oftentimes they're used to link thoughts between sentences. I might say, first, we decided to listen to Bryce's monologue without punctuation. Next, we discussed the use of a comma as a pause. And finally, we inserted the proper punctuation. See?
Yes, and I know one more reason to set off those unnecessary words with commas.
Why?
Because they indicate a natural pause in the sentence. Wow, I just thought of a good reason to use commas.
Right on the money, Bryce.
So we're going to use this activity to practice finding sentences with transition words at the beginning. We'll drag and drop a comma to the box that contains a sentence needing a comma. So which sentence needs a comma here? Science fiction is fun to read. Actually, science fiction is fun to read. Yes, right after the word actually, because actually is a transition word here. It needs to be followed with a comma. In fact, everyone loves Star Wars. Some people love sci-fi music or movies. In fact, yes, after the word in fact, you need to have a pause or a comma. Which sentence needs a comma here? Well, I don't like science fiction. She thinks science fiction is cool. After the word well, you should put a comma. Use it as a transition word. We don't watch the Sci-Fi Channel. On the other hand, we like Men in Black. So it goes here because after Men in Black, there should be the comma. Which sentence needs a comma here? Yes, commas are important, or use a comma. Save your breath. Yeah, it's going to be the top one after the word yes. Hey, I got them all right. What do you know? This takes us to your quiz. It's a 2-point quiz. Commas for transition quiz. You guys are going to complete that on your own today during our asynchronous work period. let's go and open up our another Canvas page. I'll open up all the Canvas pages separately. That way we can kind of keep all of our thoughts and things together. So let's open up Virtual Science. And then we're going to go to Modules. I know you guys know how to do this. And I'll go to the 29th. And there we are. Force, motion, and speed on the 29th. Roller coasters. Everyone loves roller coasters. I know in Columbus, I think a lot of people go up to what's that place up north? Cedar Point. I actually have never been to Cedar Point. I am more of a Kings Island person because Kings Island was only 10, 15 minutes away from my house, while Cedar Point is a good 5 hours away from my house. So that's why I went to Kings Island. But both places are great. Roller coasters. What forces affect motion and speed? The gravitational pull from the center of the Earth pulls everything on our planet downward. An object can gain energy by moving further and further away from the Earth's center of gravity. This type of energy is called potential energy. As an object increases its distance from Earth, its potential energy increases. This is the experience on a roller coaster as it climbs the tallest hill at the beginning of a ride. So if you ever go on a roller coaster, you get to that hill and it goes tick, 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 tick. You going up, that right there, you going up, that's your potential energy. You know that gravity is a force that pulls all objects towards each other. Other factors affect motion too. For example, the weight of an object and the amount of force applied to affect the speed of an object. Think about a roller coaster. Powered by a motor. The car is pulled up a long, steep hill. The car reaches the top. It is released. Then what happens? Gravity takes over. The car plunges down a steep hill and goes through a series of loops and hills and twists. The gravity is mostly responsible for the fun, but other forces are involved too. We're going to watch this video to learn more about forces, motion, and speed.
Do you like roller coasters?
Yes.
If you said yes, then you like the feel of free falling toward the center of Earth. This free fall is caused by Earth's gravitational pull. Think about the first minute of a ride on your favorite roller coaster. You get secured in and then start the slow ascent to the top of that first hill. Just as your excitement is building, so is the energy of the roller coaster. As it climbs higher and higher, the potential energy increases. Potential energy is energy of position within the Earth's gravitational field. The higher the roller coaster goes, the more potential energy it contains. If your first hill is a really big one, you are going to have quite a drop ahead of you. As gravity pulls the roller coaster down the hill, its potential energy decreases rapidly. The potential energy gained by climbing that first big hill is enough energy to power the coaster through many twists and turns, and even up several smaller hills. The roller coaster will continue in motion until it either runs out of energy on its own from friction from the tracks and gravity pulling downward, or from the brakes built into the tracks. Take a look at this roller coaster.
Wow.
Which location has the most potential energy? If you chose A, you are correct. Position A on this coaster has the greatest distance from the center of the Earth and holds the most potential energy. For those brave enough to ride roller coasters, they know that being on the ride means being pulled from side to side, forward and backward. Why does this happen? This is due to a phenomenon called inertia. All objects have inertia, whether they are still or in motion. It is the tendency of an object to keep doing what it is doing, or not doing. When the roller coaster suddenly leans left, your body is still going straight for a moment until you are yanked to the left. When the coaster suddenly goes up a hill, your body leans back in the seat for part of it as it resists the change in motion. Inertia is why you have to be secured into your seat on a roller coaster. It is also why we wear seat belts in cars. Whether you are a thrill-seeking roller coaster rider or not, You can't escape the constant downward pull of gravity on you. But roller coasters sure are a good way to have some fun with it.
Whew. That last part made me kind of feel a little nauseous. Roller coasters are a lot of fun. Hopefully, you guys have been on some roller coasters, and maybe when the weather warms up, we can go back outside again. We'll get on some roller coaster. You guys can get on some roller coaster. That'd be really fun. So, how fast can gravity pull you toward the Earth? Well, the fastest free fall towards Earth was at a speed of 373.6 miles per hour. Now that is fast. 376 or 73.6 miles an hour. And that's just free falling. That's not like a rocket behind you. That's just you just falling towards the Earth. That's fast. So that takes you to your quick quiz here. This is the force and motion speed quiz. Let's check here. So we've done our commas, we've done the position, motion, and force, and we've discussed the science, mystery science number 16. So then we need to go to the afternoon part of the day. We need to do the early years and quiz. So let's go open up Canvas again, and we will go into here and open up our social studies course. And social studies, opening up. And here they are, the early years. Alrighty, so, too far. Benjamin Franklin, the $100 bill man, explored the genius of Benjamin Franklin as a writer, inventor, ambassador, and citizen sage of the New Age. See the historic sites of many institutions he founded and an Independence Hall where he helped write the Declaration of Independence. Watch this video to learn more about Ben Franklin. We won't watch all of it. We'll watch maybe about half of it. We can fast forward.
Who wore his greatness so simply, but for every puzzle piece needed to countenance this man, there is in his life a trait, a deed, a discovery, invention that fit together and show him for what he truly was, a crowd of talents, an august gathering of human gifts. They went by the name of Benjamin Franklin. Benjamin Franklin is the grandfather. He is the president that never was, only because at the birth of the United States in 1789, he was already 83, and his personal sun, though still giving light, had set below the horizon. But what a day he had been, lusterless, warm, and bright and clear. Franklin's personal traits run deep in the American psyche. But here his presence comes rushing to the surface, bold and physical and dominant. Here in Philadelphia. For 67 years, Franklin called this city his home. Here, his fertile and far-reaching interests and influences exist in living and still productive institutions and organizations. The Pennsylvania Hospital, America's first, built in 1755. The University of Pennsylvania, which began as the Philadelphia Academy, founded by Franklin in 1749. The Franklin Institute, housed here since 1934 and established in 1824, inspired by Franklin and dedicated to the preservation and the furtherance of scientific and technological achievements. The Library Company, not only Philadelphia's, but America's first circulating library, started in 1731 by, of course, Franklin. The facade you see is a reconstruction of the original, and the building now houses the library of the American Philosophical Society, located across the street and founded by Franklin in 1743. It is America's oldest learned society. It counts over 60 Nobel Prize winners among its membership. No other city in the nation, or in the world that I can think of, is so at one with one man. As you see it, Philadelphia is a modern city. with all the modern ills and advantages. It was very different when Benjamin Franklin, age 17, first arrived here in 1723. He had already lived in Philadelphia 55 years when this view was painted. But the scene would be familiar to the boy and the man who landed that day at the Market Street Wharf on the Delaware River. 3 boats and a 50-mile walk had brought him there from New York, where he had meant to stay but couldn't find a job. He had begun the journey at Boston, where he had been born January 17, 1706, the youngest son for the 5th generation. 2 sisters were born later. His father was a soap and candle maker named Josiah Franklin, who, seeking religious freedom, emigrated from England in 1683 with his first wife, Anne. After she died in childbirth, Josiah, then 31, married Abiah Folger, 22. She was the mother of Benjamin, who was the 8th of her 10 children. When he first came to Philadelphia, Franklin was a teenage runaway, but not from his parents. It was from his brother James, who was 9 years older. In his autobiography, a graceful classic of American literature, Franklin wrote, "My brother was passionate and had often beaten me, which I took extremely amiss." These shelves hold original volumes, a portion of Benjamin Franklin's personal library. Now they're part of a priceless collection of the library of the American Philosophical Society. Let me tell you about what happened back in Boston as Franklin was growing up. He was a quick child and a ravenous reader from a very early age. Most of these books he used in his adult life. He said he could not remember a time when he didn't read. He was sent to school with the idea that he'd become a minister, but after only 2 years, the extent of Franklin's formal education, his father, because he couldn't afford it, took him out of school and tried to teach him his craft. His father, afraid that he might go to sea, apprenticed Benjamin at age 12 till he be 21 to brother James. James was a printer and Benjamin the ablest of students. This is not James's print shop, but a reconstruction on the general site of a shop where Franklin worked for Samuel Keimer as a journeyman printer soon after he came to Philadelphia. This press, on which I'm going to try to print something, is a replica.
We'll stop at minute 6. If you guys would like, you can definitely continue on your own. It's a very interesting story. Obviously, I mean, we wouldn't put an unimportant person on our biggest bill, $100 bill. So he's that important. So Ben Franklin was involved with the writing of Declaration of Independence. Who did he suggest should write the first draft? Thomas Jefferson, the person on our $20 bill. The early years. What was Ben Franklin's early life like? Ben was born in 1706 in Boston. His parents wanted him to be a minister, but was only able to attend school for 2 years because his family didn't have very much money. Back then, you had to pay to go to school. Now we know a school is free. We can all go to public school. Instead of becoming a minister, Ben, like his father, learned to make soap and candles. Making soap and candles was not interesting to Ben, so he continued on to educate himself on his own. When he read everything he could, when Ben Franklin was about 12, he apprenticed as a printer to his older brother James. Being apprenticed to his brother was not easy, and James made him work hard. During this time, Ben read a book on vegetarianism and decided to stop eating meat. He asked James to give him some extra money that was saved by Ben not eating meat. James agreed, and Ben was able to buy more books with that money. He usually ate by himself so that way he could have more time to read. Being good. What traits would you like to develop? When he was 17, Ben read a book that told how to be good. After this, he made his own list of rules for good behavior. Each week, he concentrated on one rule. The traits he wanted to develop in himself included temperance, efficiency, sincerity, and the avoidance of idleness and extravagance. He kept a notebook in his pocket so he could mark down how he was doing. So we have our own kind of journal that we guys did yesterday on Thursday, but this one's a kind of a good story. Make your own list of 5 rules for good behavior. Each day, this week, write a paragraph in your notebook about how you are doing with each rule. Be honest and also forgive yourself if you break a rule. That's a good idea. You don't have to do that, but I thought that was kind of a fun idea. So that will then take you to your early years quiz. And as we know, our very last subject for today is going to be math. So let's open up our math module here. And let's go to the one on the 29th. 29, yep, there it is. So lowest common denominator. All right, so reducing fractions, or sometimes you hear it as simplifying fraction. Reducing fraction, simplifying fraction, all the same thing. So it means you need to find a common factor between the numerator and the denominator. Watch this video to learn more about reducing fractions.
Listen closely to this one. Closer. Closer. Sometimes fractions can have different numbers but identical values.
Look at the fractions 2/6, 3/9, and 4/12. They're actually equal to one another. Fractions are kind of wacky, but this will make sense. If we look at these fractions using a pie chart, then they would represent the same fraction of the pie. Each of these fractions can be reduced to the fraction 1/3.
How do you know you can reduce a fraction?
Well, my unenlightened friend, you can reduce a fraction when the numerator and denominator have common factors, like the three fractions we just mentioned.
A factor is a vital term to have tucked away in your memory bank. A factor of a number is any number that can be multiplied by another number to get the original number.
I like it! Sounds confusing!
Actually, it's not hard at all.
Think of the number 6. Since 2 times 3 equals 6, the 2 and 3 are factors of 6. Likewise, 1 times 6 is 6, so 1 and 6 are also factors of 6. Thus, the factors of 6 are 1, 2, 3, and 6.
So to find the factors of a particular number, you just want to find two numbers you can multiply together to get that number. Now, let's return to our fractions and try to reduce them.
We'll start by reducing 2/6. Notice that both the numerator and denominator of this fraction have a common factor, 2. If we divide 2 into the numerator, 2, we get 1. Then we divide 2 into the denominator, 6, to get 3. So the fraction is 1/3.
The value of the fraction hasn't changed. The fraction has just been reduced. The value of the fraction remains the same because the numerator and denominator have been reduced by the same number, 2.
The same is true for 3/9 and 4/12. If we can divide the numerator and denominator of the first fraction by 3, then the fraction is 1/3. And if we divide the numerator and denominator of the second fraction by 4, then we get 1/3. So 2/6, 3/9, and 4/12 are all equal.
Remember, you reduce a fraction by finding a common factor between the numerator and the denominator.
Alrighty, so let's look at an example here. Reduce the fraction 4 over 12 to its simplest form. That would come out as 1/3 because 4 goes into 12 3 times and 4 goes into itself 1 time. So there you go. That's how we reduce that one down. Understanding least common multiples. In this video, Mrs. Maxfield demonstrates how to find the least common multiples of different combination of numbers.
Hi, my name is Ms. Maxfield, and today I'm going to be helping you with some problems about understanding least common multiples, or LCM. Number 1 tells us to find the LCM, the least common multiple of 6 and 9. So, this is what I'm going to do. I write 6 and 9. Now, I start out finding multiples of 6. 6 times 1, that equals 6. 6 times 2 goes here, that equals 12. 6 times 3 is 18. 6 times 4 is 24. And you can keep going. But I'm going to start doing 9 now. 9 times 1, that's 9. 9 times 2 is 18. Now I can stop because there's an 18 as a multiple of 6 and an 18 as a multiple of 9. So you can say that the least common multiple of 6 and 9 is 18. Let's find the least common multiple of 8 and 2. So again, I write the numbers one on top of the other, and then I start finding multiples. 8 times 1, that's 8. 8 times 2, 16. 8 times 3 is 24. I'll do one more. And 8 times 4, that's 32. And now I'm going to find multiples of 2. 2 times 1, 2. 2 times 3 is 6. 2 times 4, that's 8. Well, here I have the least common multiple. It's 8. And if you notice, 8 is actually one of the numbers that we started with. That's a situation where the LCM, the least common multiple of the two numbers, is actually one of those numbers. In this case, it was number 8. Okay, now it's your turn. You're going to find the least common multiple of 6 and 8.
Alrighty. We'll do a lot of practice ones together, so that's why I didn't want that last one. So least common multiples, let's compare 13 over 15s, and 2 over 25. Suppose we wanted to add or subtract these fractions. We need to find the common denominator first. We could do that by multiplying 15 and 25, but we would get somewhat a large number. Instead, we can find the least common multiple and use that as our common denominator. So in the past, remember, we would take 25 times 15 and 15 times 25 and get a pretty large number, and then we have to simplify it. Here, they're going to make it a little easier on you guys. So prime factors of the denominator. So you do 15, 3 times 5, and 25 is 5 times 5. So to find the common denominator, you just add LCM, you just add, you can just line up your prime factors so the common factors are in the same column. So there's your 5, you line them up, and now you can list each common factor in a column. So 3 times 5 or 5 times 3. So that would be 3 times 5 times 5. And then you take the product of all these factors. So 3 times 5 is 75. So your lowest common denominator here in this case is 75. Okay? Let's look at these ones. So least common to equivalent fractions. Now that we've found the LCM, let's write the equivalent fraction. So 3/15 plus 2 over 25. LCM, if 75 is our LCM, we set up our equivalent fractions using the new LCM. If we only need to find the new numerator. So we know that the bottom is 75 because we discovered that earlier. Okay, so now we define the top number, the numerator. Well, the next step is to figure out what kind of multiply the denominator by to get the new denominator, the common denominator. For the first fraction, 15 times 5 equals 75. So you multiply the top by both 5. For the second fraction, 25 times 3 equals 75. So you multiply the top and bottom by both by 3. So you come up with this one. So you get 2 over 25 times 3 over 3 equals 6 over 75, right? And then we would do 15 plus 75 plus 6 is 75 is 21 over 75, also known as 7 over 25. We'll do some practice ones here. So this is your activity sheets. Let's take a look at a couple of these guys. So I want to do a couple of these with you guys as practice. I won't do all of them. So we're trying to add some of these numbers together. Okay. So I'm going to get this up there so you can see that screen. If I go like this, you can now see my projected screen. Yeah. All right. So let's see here. Let's get a couple questions on here first. So the first one, 2/3 and 2/6. So I'm just gonna write down a bunch of problems at first. So 2/3 plus 2/6. The next one, 1/4, 1/4 plus 1/8, and then 3/8, and we can do plus 1/3. So that should be pretty good. I might do a couple more after this, but we'll see how this goes. So now that we have this, I can get this camera back up, and there you go. Now you can see what I'm doing. All right, so there we go. So what we used to do is you take the 6 over here and a 3 over here, okay? But you could also do a couple other things. Since these numbers are small, what do we need to bring this 3 to make it 6? Well, 3 times what equals 6? Well, times 2, right? So 3 times 2, that equals 6. And you do times 2 up here. 2 times 2 is equal to 4. And so our question, what we could do is 4/6 plus 2/6. If you add those together, that makes it 6/6, or just 1. Because 6/6 equals 1. Okay, let's try this next one. 1/4. So how can we make that 4 go into 8? Well, we simply just go times 2 times 2, because 4 times 2 should equal 8, and I believe it does. And 1 times 2 does not equal 8, it equals 2. And you don't have to change that. So then you have 2/8 plus 1/8, and that would equal 3/8. And you can't reduce that down any further. So this is where it becomes hard. 8 and 3. You cannot multiply anything to get to 8. So that's where this skill comes in. This is where you take this 3 over here, and you take this 8 over here. That's where the swapping skill comes in. So if we do 3 times 3 times 3, and then this 8 travels over here, times 8 times 8, then 3 times 3 is 9, 8 times 3 is 24, 8 times 1 is 8, and 8 times 3 is 24. So 9/24 plus 8/24. So that will eventually equal 17/24. We cannot reduce that. No, we can't reduce that because it's 1 and 17 is the only common factor here, and we can't reduce that down. Let's see here. We'll close that. I kind of want to do another one. Let's do it. Let's do another one. Let's try number 5. Let's see here. Let's try another one. 2/5, 2/5, and 3/10, and 3/7, and 2/3. I think that's good. Let's do 2 more. Get that back on there. Yeah, now you can see it. So for this one, 5 can go into 10, right? 5 can go into 10. 5 goes into 10 2 times. So you multiply this by 2, makes that a 10. Multiply this by 2 because it's the bottom by 2, makes that a 4. So now we have common denominator. Now we can do a little adding. So 4/10 plus 3/10. You could also subtract it this way. I'm just doing, you know what, I'll make this next one a subtraction one, just to mess around with it. And so that gives us 4 plus 3 is 7, and then over 10. You can't reduce that down. So I'll show you how to do subtraction. It's the same thing, except instead of adding, you subtract. So this one, 3 and 7, there's no common multiple there. So we go over here to 3 over there, and bring the 7 over here. So 7 times 3, multiply the bottom by 3, the top's going to be by 3, bring a 7 over here. So that means the bottom by 7, the top by 7. And this gives us our answer. So 3 times 3 is 9. 7 times 3 is 21. 2 times 7 is 14. 3 times 7 is 21. So we do 9/21. 21, and this one is 14 over 21. Really, I guess I should rewrite it as this, 14 over 21, because otherwise we'll have a negative number. We're not ready to go to negative numbers yet in 4th grade or 5th grade, over 21. So 14 minus 9 is 5 over 21, and that is the reduced amount as you possibly can go. Okay? So hopefully that helps you out. Obviously, you can pause and rewatch those parts of the video to help you out when we do the activity quiz, which here is your activity quiz, 4-question quiz. Just to quickly put a recap on this, what you need to do, first thing you need to do is watch the Mystery Science, Are Mermaids Real? And then do the discussion board post on here, discussion board post number 16. It is Are Mermaids Real? And I believe Brandon has already done his. So Mini Mystery Science number 16. And then after Mini Mystery Science number 16, you need to do the commas for transition quiz. And then you need to do the forces and motion and speed quiz. Then you have the early years quiz, and then you have the lowest common denominator quiz, what we just went over. So if you guys have any questions at all, remember you guys can reach out to me. I will leave whatever meeting I am in to meet with you, to work with you. So just let me know. I'm available all day. Use this time wisely to get these assignments done. Some of you guys might have some other missing assignments. Remember the ones I sent you on Wednesday. Another place you can check is if you simply just go into one of your courses. Let's say you go into science, and then on the left-hand side you click grades. It'll show you on the left-hand side what you're missing. Click those assignments and get those done. I'm accepting all work. Okay, I'll accept anything as long as it gets turned into me so I can grade it. If you don't turn it into me, I can't give you points. So turn in whatever you have so I can give you some of those points. So I will see you guys on Monday at 8:45. Unless you need to see me on Friday, I'm happy to meet with you. So have a great rest of your week.